Here is a tiny superpower in physics. Before you solve the problem, check the units. Suppose a pendulum has length L, gravity G, and it swings with period T. Without solving Newton's equations, dimensional analysis already tells us the shape of the answer. Length L has units of meters. Gravity G has units of meters per second squared. To make time from L and G, the only simple combination is the square root of L divided by G. So the period must look like T equals a pure number times square root of L over G. The full solution says that number is 2 pi for small swings. Why is this powerful? Units act like conservation laws for equations. A formula cannot add meters to seconds. It cannot hide an extra kilogram. Every term must carry the same dimensions. For a falling object dropped from rest, distance x depends on gravity g and time t. The units force x to be proportional to gt squared. Calculus supplies the 1/2. Dimensional analysis does not give every constant. But it can reveal the only possible scaling, catch impossible formulas, and compress messy physics into a few exponents. The recipe is simple. List the variables. Write their dimensions. Choose powers that make the target unit. What remains is often the skeleton of the law. Before the algebra gets loud, units whisper the answer.